Hi, welcome to another in my series of exam paper explanations. My name is Bill Porter. I'm the Director of Brainstorm and Tuition here in Auckland, New Zealand. Beautiful country, as you can see. And I'm going to give you an explanation about Radian measures. This is from Pure Maths 1, Paper 1, October-November 2024, Question 3. And it's 9709/11. So what I suggest you do is have a look at this question, pause the video and attempt this question for yourself. And if you have any trouble, then we can continue in scene 2, which is right here. So how did you get on? This is an explanation. We're asked to find the perimeter of the shaded region, A, B, C, D. We need to know, for a start, what AO is, because we need to know how much AB equals. AB is 15 minus AO. We don't know what AO is. So what are we going to do? Well, we need to know a few things about radian measure. First of all, the length of the arc is r theta. You need to put this in your question and answer. If you don't have one, make one up. You need to rule a line down the middle of the page, questions on one side, answers on the other, so that you can test yourselves just before the exams, not just for this topic, but for all of your mathematical topics, and in fact, all of your topics altogether. The area of a sector of a circle is a half r squared theta, where theta is in radians, as is theta here in radians. So how are we going to get x, which is the length of AO? We're going to let AO and OD equal x, and we're going to solve for x. How will we do that? Well, we have to look at the resources that we're given, and one of those resources is that the shaded region is 209 over 5 pi square centimetres. But we can also see that the shaded area is equal to the area of the sector OBC, which is this area here, minus the area of the minor sector AOD here. So what's the area of sector OBC? It's a half r squared theta from our formulas down here, and r in this case is 15, it's the large radius, and so the area of the sector is a half times 15 squared times 2 pi over 5. And the area of the small sector similarly is a half r squared theta, where r equals little x, and theta is still 2 pi over 5. Notice this cancels that 2 there, cancels with this 2 here, down the bottom. And that leaves us with 15 squared times pi over 5. Similarly here, this 2 cancels with this 2 here, and we get x squared times pi over 5. Common factor is pi over 5, and so we get pi over 5 brackets 225 minus x squared as the area of the shaded region. But the area of the shaded region is also 209 over 5 pi. And therefore this region here must equal 209 over 5 pi, which I'm going to simplify to pi over 5 times 2 over 9. So this region here equals this region here, and we can simplify this by multiplying each side by 5. 5's cancel. We can divide each side by pi, and the pi's cancel. So we're left with 225 minus x squared equals 209, x squared equals 16, x equals 4. So now that we know x equals 4, we can calculate AB, because it's simply 15 minus 4. So AB here is 11. The perimeter is AB plus BC plus CD plus DA, as I said before. So I've transcribed that down to there. AB is 11. BC is r theta, where r is big R is 15, so we have 15 times theta, which is 2 pi over 5, plus 11, which we worked out before, plus little r theta. Little r is now x, which is 4, so we have 4 lots of theta, which is 2 pi over 5, and this simplifies. 11 plus 11 is 22. Here, the 5 divides into 15 is 3 times 2 pi is 6 pi. 4 lots of 2 pi over 5 is 8 pi over 5. And from our knowledge of fractions, we know that 6 plus 8 over 5 is 38 over 5. So this part simplifies to 38 pi over 5, which is the correct answer. I hope you've enjoyed this video, and we look forward to seeing you on future videos.